Today, science is essential to our way of life. Every action we take is a product of science. Activities aimed at promoting science are fantastic in many ways. They can arouse the students' much needed passion and interest in science. The Shillong Science Center and Innovation Hub ran a 3-day science awareness program that had several positive effects on the kids. The fundamental goal of such programs is to instill in pupils a scientific mindset, problem solving abilities, the capacity for critical thought, a rise in scientific literacy, and the opportunity for hands on learning. Science awareness programs also teaches pupils to be skeptics and to challenge their surroundings. To support their hypothesis, they are required to strive hard and persist. Students can use their creativity and problem solving abilities through science. Additionally, it helps us remember knowledge more effectively. Students might consider how they can contribute to science by participating in science awareness programs. Engineering innovation or even the study of microorganisms could help us achieve this. As a result, scientists and science teachers continue to teach us about the world we live in.
Two separate pieces. Keep it joined still. And put them side by side. Make it a V. Make it a V. Make it a V. And put them side by side on the table. And complete the circle. Put them side by side. The end that you broke must be in the middle. The end that you broke must be in the middle.
That's what we have.
The end that you broke must be in the middle. And make sure they're touching. Open it up, and make sure they're touching each other. The end that you broke must be in the middle. You can't see anything. You come here. Don't make them touch. Make them touch all of them. And broken in the middle, and make them touch. Yeah, that's perfect. Okay. And make all of it flat. Touch. Open it. Open it until they touch each other. Hold it here and open as much as required to make them touch.
Oh shoot, I get another piece. Yeah, of course.
Okay. Hey, you all share? All right. Just dip your finger, water right in the middle, where it's broken, and watch what happens. Keep watching. Keep watching. Keep watching. Look what's happening.
Separating. It's turning to a star. No, this is not.
This happens because of surface tension. SURFACE, surface tension. TENSION, surface tension. Okay? Surface tension of water. In bio, you've learned, see, these toothpicks are made of wood, right?
Yes, sir.
And wood basically came from the tree. So they have their xylem and phloem. And what are the xylem and phloem? They're capillary tubes, right? They're capillary tubes, very narrow bore, the radius is very small, and there's a hollow space through it, right? This is all dry wood. Now you're pouring water into this dry wood. So what's happening? The water is going up the capillaries in this wood, and the cells of the wood, the cellulose, it's becoming turgid, it's swelling up. It's becoming turgid, right? And because you didn't break it completely separate, there are some cells which are joined, which are becoming turgid, and so the stick wants to straighten out. Because the cells inside are getting turgid. So the stick wants to straighten out, right? And that's because that happens, because the cells are trying to get turgid and the stick wants to straighten out, that's why the star begins to grow. Okay, so we have a soap film over there, right? Okay, and if I blow, then certainly it's going to blow a bubble. But can you see the colors?
Oh, yeah.
Yes? Yeah, beautiful. Okay. Right. Can you see colors? Yes. Rainbow colors? Yes. Okay. I'll only talk about the phenomenon. I will not explain it to you because it's too early to talk about it, okay? I mean, you'll have to learn a lot more physics before you can understand what's going on. But the phenomenon is basically interference of light, okay? Interference in thin films. And it's because of this interference that you see the different colors of light happening in these thin films. But anyway, I'm just showing by the side. That's not something I wanted to show really as part of my demo. It's because it's happening. All right. Can you see colors? Yes. Right? Okay. The phenomenon is because of interference of light. All right? We say interference in thin films. If you're wearing a light blue color shirt, and if a drop of water falls on it, wherever the shirt is wet, that looks darker blue, right? Why not lighter blue? Why not the same color? There's physics in that itself, that also. Again, there is interference, and there's destructive interference in that. Okay? So I'm not going to go into that just now, but what I want to do is, so this shape is predictable. This shape is predictable, it's a circle, so the film is also going to be circular, right? Well, what I want you to do is, we have this. The cube, right? I'm going to dip this in the soap solution. You tell me, what will be the shape of the soap film once I take it out? Predict. I don't expect you all to know, so it's okay if you all make a mistake. But if any of you know it, it's going to be wonderful. So you all are saying that this face will have one, this face will have one, this face will have one, that face will have one. Huh?
If you slide to one direction, it will be one.
Again. Only the bottom.
The entire thing. Yeah, but then it will, if you look here, it's going to come out. Most probably as
Circular. You said circular, all around it. Okay? So let's see, any other? Okay, so it's going to basically mimic this cube.
So it'll have a small square inside.
It'll have a small square inside. It'll have a small cube inside. And outside, nothing.
There will be.
Okay.
It'll be basically.
Okay, we'll do it just now. Yes. Look at that. Was this predictable? Now you see why science is so much fun? Huh? And from this side, it is this. It's like this. Did you all think it would be like this?
No, sir.
See that? And see that. Why does this happen? Why does it take up this? I mean, it would seem it's a complicated shape,
Yes.
right? But why does it take up this shape? Any idea?
The two bubbles go together, they hit each other and they connect.
What is the name of the phenomenon? What was the name of the phenomenon I said right in the beginning? What are we going to do some experiments on? Surface tension. Right. You see? Surface tension. So there is tension in the surface. Was this predictable? Unless you knew it. The surface wants to occupy the smallest area. And this happens to be the smallest area. That shape is the smallest area. Not all surfaces having a film. You get me? When that is the shape, is the smallest surface area. It's like a prism. So I'm going to dip in this prism now. So what shape do you predict? Similar? Something similar? Okay. Right? Look at this. There's a common line now where the three planes meet. There isn't a square anymore in the middle. There isn't a rectangle in the middle anymore. Now there is a common line where the three planes meet. Again, this is the smallest surface area. And that is why it takes up this shape. It's always going to find out the smallest surface area automatically. So a lot of times architects use the help of surface tension. They make a model and dip it in soap solution and get the shape of that smallest surface area and then plan their stuff, design their stuff. Right? All right. Tension is a force, right? Have you already learned that? Tension is a force. So when I say surface tension, it means there is a force on the surface of that film. That there's a force pulling it and trying to make it as small as possible. So when you're blowing a bubble, that surface of the bubble tries to contract in area and become the smallest bubble. Right? It wants to become the smallest bubble, and therefore the air inside the bubble is getting compressed. So if you push in a hollow tube, that air is going to come out because there is pressure. Are you getting me? That's what happens, no? Yeah. Right? If you blow a bubble and then take your mouth out, but this bubble is still there, doesn't it become small again?
Yes.
Right? That's because there is excess pressure inside. Okay, so this is a frame I've made, and I basically want this little shape in the middle to be held over there, so I've just tied it up with these strings, okay? That's the idea. All right? Now, what I'm going to do is, I'm going to dip this in soap solution. Okay? So I've dipped it in soap solution. Look at that. We got a perfect circle. And now that popped. And that popped. Okay? Watch again. Okay? Watch. Got that? Why is this happening? Again, surface tension. From this side it's pulling, from this side it's pulling, from this side it's pulling, from this side it's pulling. So if it pulls equally from all sides, then what shape will you get? Circle. Sometimes when you play games in school, in the field, all of you are holding hands and your drill teacher, PT teacher tells you expand, 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 make it bigger and bigger. So what shape do you get? Circle. That's what happens, right? So if all of them are pulling equally from all sides, then you get a circle. And this is clear proof that there is a force acting. Whichever side broke, that came in, right? Because the other sides are pulling. See, again. Now, all the films are there, so the shape is because of the weight. If I break one, you get a circle. And now one of them will break on its own, and the others will pull it. There. There. When you understand this, when you see things happening, and you study surface tension at the same time. Okay? So you want to get one more shot?
Yes, yes.
You want to get one more shot? Okay. Right? Okay. So I was thinking of giving y'all a challenge of coming up with some other creative shape. What other creative shape would you come up with? So that after popping something somewhere, selectively popping, you come up with some creative shape. Take that challenge? I don't know, you try and see if you're successful. Okay? Some creative shape. Do it? Chalo, let's do it. So that's 4 to make a square. That's 4 to make a square. thread and maybe what we need are scissors. Cut the tip and push it in. Right?
How are we going to place the thread to get it correct? From here.
Okay, it's okay. Just lift it up gently. Lift it gently. Okay, what are you going to pop?
It's a semicircle.
Okay, that's a semicircle. You'll get one more semicircle if you do this. Okay, so that's look like an hourglass now. You could say that. I got an hourglass.
The other way around. Yeah.
No. Vertical. Vertical.
No. Shubham is not in that. I know. He's,
No, because you are holding from here, Agnes. And then
Okay. Now pop the bubble carefully. What are you facing? Yeah, you did something. I don't know what you did.
Talk about it at home.
Yes, sir.
If the maid at home, explain to the maid.
I am the maid.
High five on that. High five on that. Yeah, high five on that. Doing household work is not being a maid. Oops.
Oopsie.
And I'll dip it here. See that? You know why this is happening? Hold it there. Put it in and hold it there. Look at that. Look at that. Beautiful. We are moving from surface tension. The one with the milk experiment was also surface tension. And why was that happening? Because milk has fat in it, right? And when you put the detergent in it, the soap solution, then the fat dissolves in the soap solution. And wherever you dip the soap solution, at that point, the surface tension decreases. And at other places, the surface tension is higher. So they would pull the molecules away from that place. And so you saw movement away from the place where you dipped the soap solution, right? Yes, right? So that was what was happening. So that was what about completely about surface tension. We'll move on to Newton's third law now. What is Newton's third law? To every action there is an equal and opposite reaction. Wonderful. All right. So I'm going to fold this in half and find the midpoint. Until I find the midpoint, I'm not doing anything. So we found the midpoint. So now what I do is, okay, do that much everyone, find the midpoint. Right? And then, from the side, I'm going to cut a little triangle and actually cut it off. I need to literally remove it. Okay? A little triangle. Okay? From the two corners. Hang on. Keep the holes horizontal. Okay? And press this way. That means this is going to be vertical. The holes are horizontal. This edge is going to be vertical. Are we getting that? Right? And you're going to close this end with black tape. With the black tape.
You want to be extra? Sorry, left.
So I'll clip off one corner here and make sure the hole opens up. And opposite corner over there. Here top corner I cut off. Over here bottom corner I'm going to cut off. Okay? And the hole should open up. Fine. Alright, so opposite corners. Alright? And then make it look neat and clean. Just cut cut off this extra bits. After doing that, just about 1 centimeter away from the other straw, right? Just about 1 centimeter away from the other straw, fold it and cut like the last time. One this side and one this side. Okay? Thank you. And now you have your propeller ready. If the hole is too small, we might just cut it a little more, and this is too tight, so it might not work, so I'll just make it a little bigger.
Since science is essential for good productivity and success, it's crucial that students understand how fascinating and entertaining science can be when studied outside of textbooks. It may stimulate students' interests and encourage further exploration. The goal of a science awareness program is to increase students of all ages' knowledge, enjoyment, and interest in science. Another great way to try and enhance our way of life is through science. Many of the technological innovations that we enjoy on a daily basis were aided and developed by science. Science aids us in problem solving and attempts to determine how to enhance our current way of life. How to be more environmentally friendly by recycling and doing other helpful things. Everything we do and how we do it is influenced by science. Students can improve their understanding of how and why things work through science awareness programs. It can instruct kids about the environment they live in. Science can explain the workings of intricate systems in anything from human anatomy to modes of transportation. Science provides the fundamentals of how specific devices operate from the perspective of technology. This encourages kids to think independently and may one day inspire them to create innovative technology. We may inspect items and identify differences by using telescopes, microscopes, and other lab equipments. Therefore, it is helpful to understand how they operate. This foundational technological knowledge also helps maintain small issues with household electronics. Therefore, in order to learn about the world, students engage in hands-on observation, experimentation, and discovery through scientific education and science awareness programs. Real science involves asking a question, then engaging in investigations and research to find an answer. Real science is a part of everyday life and is not just for the classroom.
Right. So there are blocks, multiple blocks. So this is a large metal block. Just like I showed. There's an obstacle in front of this. Good start.
Listen.
So I just showed you the application of a color sensor in the IR mode, right? So it's getting the reflected light. So what if you want to measure colors? Alright. So this is a machine that sorts colors. So if it sees green, then it will put it right there. And if it sees red, then it will put it right there. So this is a bot that balances itself. Alright.
Ready? Wow.
Try balancing yourself over a pipe.
Yeah. So, any questions you would like to ask Costa?
How it senses the color. Okay, so he's asking
Why this?
how this sensor measures color. Okay, so do you know that every color reflects light a different way? So that's how you see colors differently, right? Loss of reflection of light. So this sensor measures that exact thing. It sends out some light, it falls on the color blocks, and there will be different amount reflecting from it, right? So from green it's reflecting something else, and from red it's reflecting something else. And when it detects the changes and matches them according to the program. So I programmed it so that the red block will fall here. So that's why it does this. Okay. But you can do the vice versa also. So you have the sensors it's up to you how you use them, how you program them. Okay?
In physics, we learn about surface tension. We only learn about books in class about surface tension, but now we can see that we can prove that okay, there is force in surface tension, and Sir already proved us with so many activities. It was very fun.
And what about robotics?
Robotics is very interesting because to see how it is programmed and to actually see it in real, because I've watched this competition about robotics.
Yesterday we had chemistry and we visited many labs. I saw various apparatus I've never seen before. I saw lots of equipment. I was taught different things. I learned a lot. Yesterday there was also a math program where we were given activities, we were given work to do, and it was quite innovative. This has been quite fun. Today we did a bit of biology. I saw through a microscope for the first time. We did some robotics. We learned physics. We learned surface tension. I saw the dissection of a hibiscus, and it was quite fun. The center has been working quite hard towards this, and things we would have learned in class, this has been way more innovative. The same things taught in more detail, and it was more vigorous.
I'm a teacher from St. Francis, and my name is John Matthew Lingdor. So actually, coming to this program, it is such a great opportunity for our students to be able to present themselves and be here and listen to some lectures and being able to experience firsthand all the practical work and being able to expand themselves beyond classroom and expand their horizons and then come out of the shells and bubbles. So first thing first that I would like to mention about this program is that it encourages all the students that what is going to happen after class 10, because before class 10, students are not being exposed too much towards practical purpose or in terms of practical life. But after this, we can see that the students have learned what science is all about. So it will help them to also take up science and take up space in the society and be able to cement themselves.